Now, so the topic that we are going to cover today, I told you they are introduction to Python. And everyone of you installed your Jupyter notebook and you installed Angular. No? Most probably today we won't be requiring this Jupyter notebook, right? I'll show you some different types, something simpler. Then statements, expressions, and indentation, identifier, keywords, comments, variables, data types, strings, typecasting and conversion, operator.
Can you check the input device? Your voice is not clear on.
Is it?
Yeah. Go to more.
Yeah.
So speaker will be speaker. It will be a last one.
Okay.
Yeah. Microphone, take the microphone. Echo cancellation.
Okay. Is it? Okay, fine. So now let's move on to the topic, right? Why Python? So, guys, frankly speaking, compared to all the other scripting languages, I mean, Python is scripting language. You can even call it as programming language, right? Compared to all of the scripting languages or programming languages, Python is quite user friendly. It's just equivalent to talking to your system in English, right? It's that simple. So it is beginner friendly. I mean, quite easy syntax. You'll be able to learn it. I mean, with minimalistic amount of practice, right? Compared to other languages, for sure. Then used in industry in data science. I mean, there are multiple languages that are being used. Python is one of them. Then we have SAS. I don't think I'm not sure if you've heard about it. We have SAS, we have R, we have Julia, we have Scala, right? But Python is extensively used, right? Python, PySpark, they're extensively used. Portable and platform independent. Python is easy to learn and understand. Number of lines can be drastically decreased. That this is what we call code optimization, right? I mean, you don't have to keep on writing multiple lines redundantly, right? So we have the concept of functions, we have the concept of class to take care of that. Easy to debug and less error prone. I mean, with the IDE, you can very well debug the language. Dynamically typed. Now, what dynamically typed basically means is that you don't require to declare the data types, right? I mean, uh, dynamically when you type, like suppose you write so basically if I write something like a is equal to 1, if I'm declaring a variable a is equal to 1, I will not explicitly have to declare that this variable a is an integer, right? Because we know 1, 2, 3, negative 1, 2, 3, these are integers. 1.0, 1.0, 1.1, 1.2, these are decimals, right? So explicitly, I will not be required to declare that this is an integer. Python is intelligent enough to comprehend this. It will be able to understand that, okay, a is equal to 1 means a is an integer. That is what dynamically typed basically means, right? So it is a dynamically typed language, correct? Interpreted. It's interpreted. Whatever piece of code that you write, it's kind of interpreted. Then automatic memory management. So we have the concept of linked list, we have the concept of normal list, right? So I mean, in when it comes to linked list and all, if you increase the number of variables, the size of the size of the elements that are stored, it goes down accordingly, right? So it's automatic memory management, and the biggest reason why Python is so very famous is free and open source. There's no license required. I mean, there's no money that's required for using this language, right? It's free and open source. Application, the next thing that makes Python so very famous, if you're able to see, these are a wide range of applications where Python is being used, right? So web development, you can use it for data science and machine learning, for which it is conventionally used. Scientific computing, automation and scripting, right? You have Selenium, beautiful soup to do web scraping, to do automation, to do repetitive task over and over again. Game development, the Internet of Things, IoT, finance, education, healthcare, natural language processing. The latest example is ChatGPT, right? If you know what ChatGPT basically is, it's a natural language processing model, right? And we can very well write an NLP model with Python. Okay, that it facilitates us. Okay, so now the next one is Jupyter Notebook. Now, when it comes to writing Python, right? Well, we need to write Python, we need to execute Python, right? In order to practice, in order to understand it, right? So for that, we have this Jupyter notebook. This is an IDE. IDE stands for Integrated Development Environment. We have this IDE which helps us in order to write the what you call it. Python course. You can install Jupyter Notebook by installing Anaconda, right? You can install Jupyter Notebook by installing Anaconda in your system, right? But as of today, you won't be required to download it. I mean, download and install it. Installation is quite straightforward, simple, right? Because today what we are going to use is something called Google Colab. It is even, I mean, even easier compared to use of Anaconda, because it is an online source, right? So just go to your Google and type Google Colab. Go to your Google and type Google Colab. The first search, with the name of Google Colab, click on that. You'll be directed to the Google Colab homepage. This one, are you in there? You can download Anaconda later and install it. You'll get an icon like this, the Jupyter Notebook, which you can go ahead and install. I mean, you use it, right? So, are you on this homepage, everyone? Just click on New Notebook. It might ask you to sign up. If you already do not have an account, sign up with your Google account. So this is the environment wherein you will be writing the code. Yeah, yeah.
Excuse me, sir.
Yeah,
Sir, can you please repeat it?
yeah, sure. Go to Google and type Google Colab. Google Colab, this Google Colab. This is what you need to type. The first search page by the name of Google Colab, click on that. And you will be directed to this home page, Google Collaboratory. Are you there?
Yes, sir.
Perfect. Click on new notebook. This one. Click on new notebook. And then you'll be guided to an IDE like this. A notebook like this, right? Everyone? In there? Perfect. Are you there?
Yes, sir.
Perfect. Perfect. So now this is where, I mean, this is the online resource where you'll be able to write Python codes, write and execute Python codes. Okay. Now, this Google Colab comes with multiple. I mean, this Google Colab is basically a product of Google. This is a product of Google and Python IDE that is developed by Google, right? And you will be able to write and execute your Python codes on this, correct? Now here, okay, I'll tell you. I'll tell you as we move ahead. So here, if you see file, you'll be able to see these upload new notebooks, open notebook, upload notebook. So these notebooks should be in .ipynb format. .ipynb format. If at all you have any notebooks that have been shared to you by BI earlier, the IPYNB notebooks, there is the extension for the Python notebook for Python notebook. So if you have any of these, you can very well upload that notebook over here, right? Using Open Notebook, you'll be guided to all these IPNYB notebooks, right? You can even go to your system by upload, right? Do a browse, you'll be taken to your system, right? So you can upload a new notebook. You can rename the existing notebook. This is the name. This is where the notebook is named, right? So currently it's named as untitled 7.ipynb, right? This ipynb that you're able to see, this is the extension of a Python notebook. Any ipynb file will have Python codes in it, right? Now, then, okay, yeah, you can move it to any folder in your Google Drive. This will be by default. This will be stored in your Google Drive. Guys. Okay. You can move it to trash. You can save a copy in Drive. If you do this, it will create a copy in your Google Drive, right? In GitHub, just if you have GitHub account, you'll be guided to the GitHub account and you'll be able to save the copy over there. Save is going to dynamically save, right? You won't be required to explicitly save it, right? Because it is an online source. It will get saved dynamically, right? As you write, right? Save pin, revision history, right? Download and print. So if at all you want to download this notebook, you can download this notebook in two formats. One is in the .ipynb format, that is Python notebook. It will be downloaded as Python notebook, which you can explicitly open in your Jupyter once you have it, right? So let me even open Jupyter and show you, right? This is how your Jupyter notebook is going to look like. Now let us say I go to and let me open logistic regression. So you can see that we are able to see an entire Python code over here, right? So this is how Jupyter Notebook basically looks like, right? This is for opening this, you'll have to download a Jupyter Notebook from Anaconda. First, you'll have to download Anaconda, then install it, and then you'll be getting this icon in your start menu, right? Which you need to open. This is going to open a Jupyter notebook for you, right? But today, it's again, I'm repeating, today it's not required. We'll be working on Google Colab. Okay. So using the Jupyter notebook, you can open any of the IPNYB files that you've downloaded, right? or the .py file. .py file you can open with any of the query editor like Sublime Text or anyone that you basically use. A .py file is a Python file, and .ipynb is a Python notebook, right? That's the difference between two, right? This is a Python notebook. It cannot be opened with a Notepad or Notepad++, but .py file is a Python code. It can be opened with any query editor, okay? Then these are the edit options. Some of the edit options, right? View. These are the view options. How you can view your collab notebook. Then you have insert. Insert if you want to add any code, any text cell, or if you want to insert, you can insert directly from here as well. Just hover over the bottom. You'll be able to see code and text, right? I'll tell you what basically these two are going to do, right? What is the difference between? Then you have scratch code cell, code snippets, add a form field. Then you have runtime. Runtime is all about, I mean, see, whenever you open a Google Colab notebook, there's some memory that's being allotted, right? So if you just press on connect over here, if you just do connect over here, you'll be able to see the memory allocation that you've been given to this notebook. So let it connect, you'll be able to see. So this is what basically runtime is, right? You need to connect to your runtime to execute the code. So see, if you hover over it, the RAM is 0.12.68 GB on disk, 26.88 GB, 107.72 GB, right? So these are the alternate ones that you can use, right? So, and if you see the language connected to Python 3 Google Compute Engine backend, and this is where you'll be able to execute the Python codes, right? It's going to connect you to Python 3 by default, okay? The Google Colab. Now, if you want to run all the cells, then you select run all. It's going to run all the cells throughout. Run before, it's going to run all the cells before the selected one. Run the focus cell, the cell you are upon. It's going to run that. Run selection. Run after. It's going to run all the cells after the selected ones. Interrupt execution. If at all you think that execution is taking a lot of time, you can stop the execution, restart session. It's going to remove all the cache, everything that you have run. Restart session and run all. Again, it's going to execute all the cells after restarting the session. Disconnect the session. So every time you basically open a Google Colab, right? There's a session that is connected, right? And that connection generally stays for, I suppose, 9 or 10 hours, right? Now, if you want to reconnect the session by some due to some problems, you need to reconnect the session. You can just go over here and disconnect and delete runtime, right? And then again you can connect it. Then change runtime type. There are three types of runtime. The CPU, that's going to run on your on the CPU, the memory of your laptop. The T4 GPU. GPU stands for graphic processing unit. Every one of our laptop has some graphic card, right? It's going to use that graphics unit. But generally, the GPU is used if you are running any deep learning models, some big models, right? And then the TPU, that is the tensor flow processing unit. Again, TPU uses the again it's used for the deep learning models, right? If you're working for deep learning models with quite a big data. Manage session, view resource, view runtime log. You can see all the logs that are happening, right? Okay, then generally this help you will have the FAQs and all these, right? Now, so this is the Google Colab that we are going to work on today. Okay. So moving ahead. Okay. So now if you're able to see, in this Google Colab notebook, I'm showing you text over here, right? I'm showing you text over here. Now there are, as I told you, there are two types of cells, right? One is the code cell, one is the text cell. When I click on text cell, I will have something like this. I will have something like this, right? So basically, I can display to the end user, I can display any text like this, right? So I mean, a triple hash over here is used for heading. Remove it to, I mean, remove one single hash, the heading gets bigger and bigger, right? It gets bigger and bigger. So this is how you can present your code. You can put some text inside your code, right? If at all you want. This double star over here, it's going to bolden your this thing, right? It's basically bolden the format. If you remove this double star, it will, I'll just, you see, so there's no bold now, right? So to bolden, you can add a double star. It's going to bolden your this thing for font, right? This can be done with the text cell only, right? This can be done with the text cell. You cannot do this with the code cell, because once you create a code cell, in this code cell, the Google Colab explicitly, it expects Python code. If you try writing text over here, if you write text over here, it's going to return you an error, because this is not what it is expecting. Just a second, let it connect. Yeah. See, it's returned me an error. Why? Because the code block cannot take in text as input. Once you create a code cell, it's going to expect a Python code. Once you create a text cell, there you can write anything, right? The text cell can intake anything, right? So now to begin with the introduction, Python is a programming language used to create software and programs, and it's especially popular in field of data science. I mean, Python started growing by the name of data science itself, right? I mean, with machine learning, data science, right? Python kind of grew. With Python, you can analyze data, create graphs, charts, right? So, I mean, for data analysis, we have multiple libraries. We have the NumPy, SciPy, Pandas. Then to create graphs and charts, we have libraries like Matplotlib, Seaborn, right? Which creates visuals, and even you can build simple machine learning model to predict outcomes. I mean, not simple. You can even create deep learning models as well, right? Complex models as well, using Python. So whether you're working with customer data, financial data, or any other kind of data, Python has tools you need to make sense of it all, right? Because when it comes to data analysis, right? If Python is helping you out with data analysis, it's going to help you out with any data that you have in the market, right? So you can, irrespective to the type of data, be it a structured data, be it a non-structured data, be it an image, be it an audio, video, anything can be read using Python. Okay. Now, why Python? We have already seen that it is simple, easy to learn syntax that is designed to be readable and resembles the English language. Straightforward, right? It's very simple. You'll be able to understand it, right? How simple this is. This makes it easy for the beginners to write the code and understand what is happening in their code. Python has a vast array of libraries. This is very important at this point. Vast array of libraries, and every library basically is a Python code which is contributed because it's an open source language, right? So anyone can contribute it, right? And generally, maximum of the times we have company like Google or Microsoft, people from Google or Microsoft who are donating these libraries to the open source Python, so that these libraries are basically written to make the life of the coders easy, right? And tools that are specifically designed for data science, including these are some of the libraries: NumPy, Pandas, Matplotlib, and scikit-learn. Now, NumPy is a library for numerical. NumPy stands for numerical Python, right? Pandas is a library to read the data, to read the structured data, to be more specific. Matplotlib is a library to create visuals, the pie chart, bar chart, scatter plot, all these, right? And then scikit-learn. Scikit-learn is a library explicitly which consists of algorithms of machine learning, right? Basic algorithms, or you can say advanced algorithms, all of it, right? Python has a large open source community that provides support. So there's something called Stack Overflow, right? Stack Overflow. If you go to Stack Overflow, it's basically a large open source community for every language. But you'll find many of the FAQs or many of the questions which are related to Python on that, right? So it has a very large community support. And it's a flexible language that can be used for a wide range of data science tasks. Not only data science tasks, but we have already seen what all tasks we can accomplish using Python, right? These are all tasks that we can accomplish using Python. So basically, it won't be wrong to say that Python is a multiple utility language. It's a multiple utility language. I mean, it's not restricted to data science and machine learning, unlike R. R is a language which is explicitly used for machine learning, but Python can be used for web development, for ML, for scientific computing, automation. Apart from that, Python can even be used for deploying the model in the working environment, right? So, okay, so these are the advantages. Why exactly we require Python, right? Now, where do we practice the coding? We practice the coding with an IDE, Integrated Development Environment. IDE is nothing. Every language has an IDE, right? Because every language we require some of the other development, right? We require to write the logic, we require to test the logic, and that we do with the IDE, right? IDE stands for Integrated Development Environment, an environment that helps us develop the develop the logic, right? Write the language and develop the logic. Some of the IDEs that we have specifically for Python are PyCharm, Spider, Idle, Jupyter, Visual Studio, right? Visual Studio is nothing but a query editor, right? And then Google Colab, right? Out of all these, most of the times that anyone uses an IDE is either a Jupyter or Google Colab, right? There are some what do you call it, drawbacks with Google Colab. It is the memory, right? The free version does not give you much of memory, right? I mean, if you try working with big model, if you try working with big data and complex model, it might get crashed, right? So in such a case, then you can very well go ahead and use Jupyter, correct? Fine. Then why Google Colab? For it's the easiest IDE for beginners, web-based platform that does not require any installation or setup, right? That's the main thing. Because if you were to use Jupyter Notebook, you would have required to download this, install this, and then open the Jupyter Notebook, right? But here, Google Colab, just go to the home page, click on your notebook, and the Python IDE is in front of you, correct? As simple as that. Just what you require, the prerequisite are a Google account. It offers free environment for the users to run and execute code that we are going to do. Okay. It allows for collaborative work and sharing of code and notebooks. I can share my link with every one of you, right? Share. I just do share over here. It will be restricted. Access will be restricted. I can just convert it to anyone with the link. Now, if I share this link with you, you will be able to open this Google Colab in front of you, right? I mean, the notebook that I've created, you will be able to open that in front of you, right? You won't be able to edit it. You will be able to open it, right? Then once you open it, you can just go to the file, save a copy in the drive, and you'll be able to then execute that as well. Okay. It comes with pre-installed libraries and tools commonly used in data science, right? So we have NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, which are already installed in Google Colab. Okay, you just need to import them. That's it. So this is about Python, right? This is basic about Python, right? The theoretical part. Let's execute our first code. So what you need to do is you'll be having this code block in front of you, right? You'll be having this code block in front of you. Just print hello world. So write print. Yeah, print hello hello world. Write this, and to execute it, press shift and enter combined together. Shift followed by enter. Shift followed by enter. Are you able to get this executed? Shift followed by enter.
Hello world.
Huh?
Hello world.
Yeah. Now, just remember that I'm putting inverted commas over here. I'm putting quotes over here. Single or double, whatsoever it is. You need to put that. Done? Shift followed by enter. Both together. Shift, enter. Done? Executed? So, this is how we execute our Python code. Write a code over here in this cell. Every cell is different, right? Every cell is different from each other. So write a code over here, shift followed by enter, you will be able to see the output. Now here, the output that here we are able to see hello world, because the command that I've written is a print command. Print command is used to display the output. Print command is used to display the output. Okay. So the basic most command is print command, which helps us display the output. Now over here, the output is hello world, a string called hello world. I'll go to what is string later in the session, right? But what we are trying to print, we are trying to print a string called hello world. Okay, and that is what it's done. It's returned as the exact same string that we have passed in the parentheses. Okay. So this is our first Python code. Okay. Now, moving on to statements, expressions, and indentation. Now, guys, this is important part in Python. Okay. This is one important part in Python. Now, see, a statement is a complete line of code that performs a specific action. Now, suppose uh, from our childhood, right? We have been learning one thing, right? If you uh, suppose we are given any worded problems, right? I mean, since the time we've been learning worded problems, suppose there are 10 apples, 4 apples are given to someone, how many apples remain? So what do? X is equal to 10. The remaining apple is equal to 10 minus 4, that is equal to 6. Now here what we have done, here we are creating a variable and we are assigning, here equal to means assigning. We are assigning a value of 10 to this variable, right? So what we have done, I mean, if I translate this into English, it will be X is a variable which has a value of 10. This is a statement in Python. This is a statement in Python, right? We call it as an assignment statement. In Python, we call it as an assignment statement. Now 10 minus 4, again, 10 minus 4, what we are doing? We are subtracting 4 from 10, right? And we are will be assigning it to a variable called r. This is a statement in Python. This is an expression in Python, right? So basically, anything, anything that is serving some purpose in Python, be it any logic or be it any assignment, be it any check, anything, it will be called as an expression in Python. Okay. So statement is a complete line of code that performs specific action. Example includes assignment statement, loop statement, conditional, and function calls. Right? I'll talk about this in the subsequent sessions. So assignment statement. This is an assignment statement. X is equal to 10. Right? Now let me tell you what this assignment statement is doing. In Python, when you write X is equal to 10, the operator understands, the Python operator understands that we have created a new variable called X, and equal to means we are assigning a value of 10, right? So next time, whenever you call this X variable, it won't be treated as X. It will return you the value that X stores, right? It's like, let me show you. See, in Python, in Python, you have some memory storage, right? You have some memory storage. X is equal to 10. These memory are in form of buckets, right? These memory are in form of buckets, right? So small buckets, right? It's just like every one of our address, right? These are just, you can say this is one residential area and these are buildings, right? So suppose if I stay over here, right? If I stay over here, I will occupy this building. I will be occupant of this building, right? And secondly, I will have some address, right? This building is going to have some address, right? So similarly, when I write x is equal to 10, x is equal to 10, there is one bucket that is going to store this variable x, right? Will be initiated by this variable x, and it will store the value 10 inside it. So whenever you access that memory location, it is going to return this value 10. Let me show you how. So x is equal to 10. Now if I do print x, it should return me the value that it has stored. Execute it, it's returning me 10. So basically, what I have done right now is I have created a variable. This is the variable, right? On the left-hand side, whatever you're going to see, that will be called as a variable, right? Variable or an identifier, okay? So X is a variable, and I have initiated a variable and assigned it a value of 10. Whenever I call this variable here on, in this notebook, right? Not in some other notebook, right? If I'm declaring X over here, it won't work in the other Google Colab notebook. It is going to be notebook specific, correct? So X is equal to 10. the next time I call x, right? I print x or I add x to anything, it will return in adding of 10, or it will return in calling of 10. It will return me the value that is stored. Okay, perfect. So here, this is assignment. This is assignment statement. Assignment means nothing. We are assigning a value to a variable. As simple as that, right? Now, this is a single assignment statement. We have multiple assignments as well. We have multiple assignments as well. Suppose now I want to assign x by 10. I mean, I want to assign value of 10 to x. I want to assign value of 20 to y. I want to assign value of 30 to z. That means I have three output values. I need to assign them to three different variables. You can do a multiple assignment like this in Python, right? You can do a multiple assignment like this in Python. X, comma y, comma z is equal to, again, assignment operator, 10, comma 20, comma 30. Now what it is going to do, it is going to assign value 10 to variable x, value 20 to variable y, value 30 to variable z. Okay, so I mean, this is how flexible Python is, right? It's not that you'll have to single, I mean, in one line you can just assign a single variable, something like this. It's not the case, right? You can very well go for multiple assignments, right? Comma separated multiple assignments. X output 1, y output 2, z output 3. As simple as that. If you do a print x, print y, print z, let's do one thing. Let's do one thing. Rather than using 10, 20, 30, let us let us use 1, 2, 3. Let us use 1, 2, 3. Right? Execute this print x, print y, print z. What do we expect in these three print statements, guys? Can anyone tell me? Print x, print y, print z. What should I expect over here? What should I expect the output? 1, 2, 3. 1, 2, 3, x is 1, y is 2, z is 3. Correct? So here we have been able to learn multiple assignment, but if you look closely, you can find one more thing that is happening over here. You can find one more thing that is happening over here. Earlier, I assigned, okay, just execute it. Earlier, I assigned value of 10 to x and printed that value. It returned me 10. Now I am assigning value of 1 to x, and when I do print x, it is assigning value 1. What are we able to understand from here? The value can be updated. Value of any variable can be updated. As you go ahead into the code, it's not fixed that if you're writing x is equal to 10, it's not fixed that throughout the code it will be 10. You can very well update the value. You can reuse the variable, right? You can reuse the variable. You can update the value at any point of time, right? But again, you will have to use that assignment operator. Correct? You will have to use that assignment operator. So variable can be updated at any point of time. Okay, that is the next step. Variable reuse, right? Variable reuse. Now see, I'm assigning x is equal to 5. I'm assigning x is equal to 5. I'm assigning a value of 5 to x. Then I'll do print x. This should return me value of 5. This print statement should return me value of 5. Okay. Then I write x is equal to hello. Earlier I assigned a value of integer. Now I'm assigning a value of string. right? I'll go to string, what basically it is, right? But if you see, these two values are different. And now when I print x, it should print me hello. So the first print statement should return me 5. The second print statement should return me a string. When I execute this, see, within one cell itself, I've been able to update the value of the variable x. Make sense? So we have basically reused the variable. You can very well update the value of the variable. You can change the value of the variable by assignment at any point of time in your code. Guys online, are we clear with the topic until now?
Yes, sir.
Okay, perfect. Thanks for the confirmation. Next is the print statement. The first one that we saw was assignment statement. We assign a value to a variable. The next one is a print statement. We print the output, right? We print the output. So print statement basically helps us to print whatever is there in the parentheses, right? If I pass a variable x is equal to 10, print x, it's going to return me the value. If I pass hello world as a string itself, it will print the entire string as it is, right? So the next one is print statement. Print is again a statement, right? Like assignment was a statement, print is again a statement. It's going to return the output that I'm willing to print. Okay. Next is conditional statements. Next is conditional statements, right? So conditional statements control the flow of execution based on conditions. Now, whenever you write a code, whenever you write a code, there are always, there are always conditions that need to be satisfied, right? That need to be satisfied. To kind of get these statements into Python, we have the concept of conditional statements, right? Now, suppose in the given example, if x is this is greater than operator, right? We'll talk about the operators as well, right? If x is greater than 5, right? Print x is greater than 5. Else print x is not greater than 5. Okay, so let me pass the value of x over here. I'll pass some value of x over here. X is equal to 10, let's say. If x, that is the value that is stored in x, is greater than 5, print this statement. Else means if this condition is not true. If this condition is not true, if the first condition is not true, print x is not greater than 5. Now, when I put the value of 10 to x, when I assign the value of 10 to x and execute this, see what is the output? X is greater than 5. Right? X is greater than 5. Why? Because it compared the existing value of x with 5 and it executed this statement. Now, if I change the value to 2, this condition will not be true. The second statement will be executed. X is not greater than 5, right? So if you want to put any conditions, incorporate any conditions in your Python programming, you have the concept of conditional statements. You have the concept of conditional statements, the conditions, right? You can very well put these conditions, okay? And finally, we have the concept of loop statements. We have the concept of loop statements, right? Loop statements means it's just going to loop over. It's just going to loop over, right? What do I mean by loop over? So, suppose, let us say that I have some. Now in Python there are some data types which are multiple data types, right? Like let's say a list. I talk about this in tomorrow's session, right? A list is something like this. It is going to store multiple values. Now suppose if I want to find the square of these 5 numbers, I want to find square of these 5 numbers and print them conventionally without loop. What I would have done, print 1 square, print 2 square, print 3 square, print 4 square, print 5 square. Print first statement, print second, third, fourth, fifth, right? Print 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25. Instead of these 5 statements, because again, right, these 5 statements are redundantly going to increase the length of the code, right? And I don't want, frankly speaking, when it comes to coding or so, right? We generally with optimized code, we have, when it comes to like industry standards, we generally have nearly 24 or 2500 odd lines of code in Python, right? That's how big the codes are, right? And in such big codes, such redundancy would take the codes to more than 10,000 lines, which will be very difficult for anyone to read. Anyone who has written the code, it will be difficult for him or her to read, right? So how we can remove this redundancy? By using the concept of loop. By using the concept of loop. Now, what does this loop do? I'll just tell you in brief. The details we'll talk in the next session, right? What does this loop do? Loop iterates over every single elements one by one. Every single element, right? So first it's going to take the value of 1, then it's going to take value of 2, then value of 3, value of 4, value of 5. Just one print statement. This is the loop statement, and here one print statement, print I raised to 2. So when I write a loop statement, it's going to iterate over all the values one by one and print the square of all the values one by one. So print 1 squared, print 2 squared, print 3 squared, print 4 squared, print 5 squared, right? So instead of writing these 5 lines, now I'm able to get the work done in 2 lines, right? So to execute any piece of code repeatably, right, or repetitively, I can use the concept of looping, correct? Now see, range 5 is what? Range 5 is 0, 1, 2, 3, 4. Range 5 is 0, 1, 2, 3, 4. In Python, generally the last value is not considered, right? So for I in a range 5, that is range 5 is nothing. It is 0, 1, 2, 3, 4. Print I, it's going to print the value of I. So first it will print 0, then 1, then 2, then 3, then 4. Correct? So this is the loop statement. This is the loop statement in Python. So these are some kind of statements in Python that we use. Okay. Then expression Expression is nothing but any arithmetic addition, subtraction, division, multiplication, or any multiple logic that you write, right? Anything, your standard deviation, mean mode, median, anything, right? If I write x into y divided by 5 plus z minus 1, anything, right? This is an expression. This is an expression, right? This is an expression. So any such logic that you write, it will be counted as an expression. Any big logic, right? Not the assignment one, but any big logic that you write, something like this, right? Addition, subtraction, anything. You do any logic, right? It will be considered as an expression. It's a combination of values, variables, and operators that can be evaluated to produce a result. So here I am assigning, written an assignment statement, and here I am adding 3 to this already created variable, that is x. Now, once I create this x is equal to 5, x will store the value of 5. When I call x over here, it will return 5 plus 3. Y should have the value of 8, which it has. Make sense? So this is an expression. This is a statement. Okay? That's the basic difference in Python, but I mean these words are kind of used interchangeably, right? You can just go ahead and write this piece of code. Guys, online, any question, any doubts? Online, offline? Okay. Next, we move to the concept of identifiers, keywords, and comments. Now, as I told you, right, while writing any program in Python or in any language, oh, you're writing, yeah, writing any program in Python or in any language, we need to store the output values. I mean, we write logic. Logic gives us output. Those output needs to be stored at some point of the time in your program. For that, we have the concept of variables. For that, we have the concept of variables or identifiers, right? So variables and identifiers, basically, I mean, the difference between the identifiers and variables is like whenever you write a class, you write a function in Python, those will be called as identifiers. And wherever you write an assignment statement like this, it will be called as a variable, right? So coming to the identifier of the function, we'll talk about it later, right? In the subsequent sessions. Today we'll talk about variables in Python, right? So like suppose I'm writing this name is equal to John. Name is equal to John. That means I'm creating a variable called name and I'm storing a value called John, right? So this is a variable in Python. Anything that you see on your LHS, that is the variable in Python. Age is equal to 30. Now, there are specific rules to create a variable, right? You cannot name the variable as you want. There are specific rules that are required to create a variable that are defined. Variable name must start with a letter or an underscore. That's it. Alphabet or an underscore. That's it. Correct? Second, the remainder of your variable may consist of letter, numbers, and underscores only. No special characters allowed. In your variable names, you cannot use any special characters apart from underscore. That's the only special character that you use. It begins with alphabet or underscore, and once you have written your first character, you can go ahead with letter, numbers, or underscore. That's it. Correct? So spacey one, PYTHON here, T is capital, machine learning are some valid names. Correct? Spaces not allowed. Spaces not allowed. Names are case sensitive, a very important concept in Python. Python is case sensitive. Python language.
Just for variables.
No, Python entirely is case sensitive. So let me show you. Execute this. X is equal to 2. Now here I just want you to see the difference in the font. See the color of this font and see the color of this font. This is black. This one is different font, right? Some brown or something like this. Are you able to see the difference? I have not made any spelling mistake. It's the same. PRINT, PRINT. This executed, this did not. Why? Because Python is case sensitive language. Variable name, function name, anything, it's going to be case sensitive throughout, right? So if you're declaring small x, and if you try to print the uppercase x, name x not defined, case sensitive, right? Python is a case sensitive language. You cannot change the case in Python, correct? It's a best practice to create a variable that should be coherent with the context you're working on, right? So let's say you're working with a fruit data, the variable name should be fruit or fruit mango, something like this, right? I mean, this is the best practice. This is the best practice, right? So let's try out some of the variable names. So see, first I've tried beginning with a letter. 1 O none, right? 1 O none is equal to 4. Execute it. Syntax error. Syntax error, right? Syntax error means, syntax error can mean anything, but over here it means that the variable name that is being created, it's not correct. Why it's not correct? Because I've tried to open the variable name with a number, which is not correct. There are rules, right? Right now we have seen the rules. It should begin with an underscore or a alphabet, correct? I tried to begin it with number, error. I tried to give a space over here in the variable name, execute it, error, invalid syntax. I tried to use a some special character at the rate, try to begin it with some special character apart from underscore, error. But now I try to begin it with an underscore followed by alphabets followed by underscore, execute it, execute it. Fine. Now I begin it with an underscore, and the lag are the lag characters are the variable, but I'm trying to incorporate one special character, that's at the rate. Execute it, an error. Why? Because at the rate is not a character that you use while naming a variable, correct? Then I use a hash, p is not defined, right? Because hash, if you've been noticing, wherever I put hash, it's basically changing the font color, right? In Python, hash is generally used for commenting. In Python, hash is generally used for commenting, right? So wherever you put a hash, that line will not be executed by Python. Will not be executed by Python at all, right? Hash is used for commenting, right? I'll come to that. There's something called single line comment, there's something called multiple line comment. Okay. Then again, I try to begin with a name, error, right? Then keyword, then keywords. In Python, there are certain specific keywords that are used. Those keywords are already defined in Python while it was created, right? Those were already defined in Python. One of the example of keyword is if, or else, or for, right? These keywords are written for specific purposes. Every one of them serves a specific purpose. If statement serves a purpose for condition, else serves a purpose for alternate condition. There is something called elif. It's again an alternate condition. For serves a purpose for loop, correct? So every keyword in Python is written for some specific purpose, right? Now, if you want to check the list of keywords, right? Just write an import keyword. Again, keyword is small library that we have in Python, and print keyword.kwlist. Kwlist is nothing but keyword list. When you execute this, see, it gives you a list of all the keywords that are present in Python. False, none, true, and, as, assert, async, await, break, and so on and so forth, right? And generally, it's a good practice that we don't use these keyword name as variable name. We generally don't use it, right? To avoid confusion, correct? To avoid confusion. If you write if is equal to 10, and then if you want to write a conditional, right? It's going to confuse you and Python, both of them, correct? So generally what do we do? The best practice is we don't use these keywords for the variable names. We keep them separate. Separate variable name, separate keywords. Don't mix them up. Okay, that creates a confusion. Already we have a lot of problems in our lives, right? So we don't try to increase our problems by doing such things. Okay. And then comments are annotations in the code that are ignored by the Python interpreter. Anything that follows a hash in Python code, it's going to be ignored. It won't be executed, right? So if you see over here, if I suppose, just let me just remove this hash, and now let me try to execute. It's going to return me an error, invalid syntax. This is a text. This is not a Python code. This is not what code cells expects, correct? So in such a case, if you want to write, I mean, if you just want to write why exactly you've written this code, because now suppose, let's say you write this code today, and 2 years later you have to revisit the code. There's some complex piece of code that you've written, right? 2 years later, when you work on multiple projects, you'll not be able to remember why have you written this code. So this time, what you do while writing the code itself, you write a comment over it, so that 2 years later, 3 years later, 10 years later, if you or anyone else comes and tries to access the code, execute the code, he or she will be able to understand that, okay, this logic has been written for this purpose, correct? Now, when I put a hash in front of it and execute, it is going to get executed. Why? Because hash followed by anything will be a comment. Won't be executed by Python interpreter at all. Now there are two types of comment. One is a single line comment. There's a single line comment. Now, suppose I begin with a hash, press enter, and I write anything below it. It won't be treated as a comment. It won't be treated as a comment. If I write hash, anything following hash in this entire line will be a comment. Anything in other line will not be considered as a comment. Okay? So this is an example of single line comment. But if you want to write a multiple line comment, we use the concept of docstring, right? We use the concept of docstring. The concept is called as a docstring. The concept is called as a docstring, right? That's a triple quote. Triple quote. Now, triple quotes can be a single or a double quote. Anything, right? It can be a single quote like this. It can be a double quote like this. It's perfectly fine. Okay? Single quotes and double quotes do not matter in Python. But there's only one thing: if you begin with a single quote, end with a single quote. If you begin with a double quote, end with a double quote. If you begin with a single, end with a double, it's going to return you an error. That's not acceptable. Begin with single, end with single. Begin with double, end with double, right? So a triple quote over here, three quotes over here, and you can write any number of lines in between. I can write an entire paragraph, right? I can write an entire paragraph. It will be treated as a comment. This won't get executed. And this is the concept of multiple line comment in Python. Single line comment hash, multiple line comment docstring. Multiple line comment docstring, right? So see, variable is equal to 42. Then then basically I write a comment and try to execute this. It will get executed. See, it got executed. Why? Because the Python interpreter executed until here, found a single line comment, ignored it, and then executed this print statement. That's it. So within this entire within this code, this part was ignored. this part was ignored. Okay. So this is how your comments work. Fine. We'll take a break of 5 minutes and then we'll begin with the data types in Python. Right? We'll begin with data types in Python. Okay.
will be using these things for data analysis also.
Data analysis service.
We will be using these things also.
Yeah,
We are learning.
yeah. Now, the next topic is data types in Python. Now we'll begin to get into some depth in Python. Okay, data types in Python. So until now, what we've seen is kind of basic things in Python. Now we are going to delve into some details, right? Some things that are going to be used extensively in Python. Okay, data types in Python. Now, whenever any language is created, the first prerequisites of any scripting language or any programming language, because the end aim of the aim of any language, the purpose of any language is to enable the user to create some logics, right? For that logic, the language should incorporate certain data types, right? And in Python, these are the important data types that we have, correct? Text type, text means any alphabet, alphanumeric, or special characters. They are considered as text in Python. Okay? It will be considered in the data type of string, str. Numeric types, there are multiple numeric types in Python. The data types would be integer, float, and complex numbers. Correct? Although we have seen the complex numbers, but generally we don't use complex numbers in our real world. Okay, we know the concept of complex number, but we don't use them in our real world. So here the most important numeric data types are integer and float. Integer, normal integers, and float are decimal values. Okay. Sequence types are nothing but data types that store multiple values in them. Data types that store multiple values in them. So we have list, we have tuple, we have range, correct? Then we have mapping types, dictionary. Dictionary in Python does the work of mapping. So you'll be able to learn all these things in your subsequent sessions. Set type, set and a frozen set. Boolean types, we have Boolean values. Generally, there are two Boolean values, either a true or a false, right? Binary types, right? The bytes, byte array, memory view, and none type, that is null values, right? Wherever the value is missing, be it a table, right? Be it any Excel table or anything like that. If we talk about this, so if I have some Excel table like this, right, and I have some values 1, 2, 3, 4, 5, 6, 7, and 9, right? So there's a missing value over here. This missing value in Python will be called as a null type or a none type. It's a missing value. Generally, in Python, it's called a none type. Okay? Missing value or no value at all. Okay? So see, data types in Python, description represents numbers. Represents numbers. Now it can be a positive, it can be negative, whatsoever it is, right? So age is equal to 25. Let's try this, right? Let's try this. Age is equal to 25. Okay. Age is equal to 25. Correct? Age equals 20. Okay. Now, if you want to find out, suppose now I've created a variable called age, right? I'm assigned the value of 25 to it. Suppose in Python, if you need to check the data type of a variable, we have a function called type. Type, type. It's a function that returns you the data type of any variable. So type parentheses, and in this parentheses you will have to pass the variable for which you are checking the data type. So type age. Once you execute this, it's an integer, right? It's an integer. So see, type age is an integer. Now let's do minus 25. That's 0 minus 25, execute, it's an integer, right? So using a function called, now this function is inbuilt function in Python. It's already present. When Python was created, this function was incorporated in it already. So type, it returns you the data type. You can check the data type of any variables using a function called type. Okay, so type parentheses. In that parentheses, you need to pass the variable name. It returns you the data type of the variable. Correct? So age is equal to 25. Type age is int. This means 25 is considered as an integer. Right? And this is what I mean by dynamically typed. I pass 25, it's going to be treated as integer. Now, let's take some different example. Okay, GPA is equal to 3.75. GPA, I'll create a variable GPA and assign a value of 3.75 to it. Now let's check the type. Float. So basically, when I declared 25, automatically it understood that this is an integer. When I declared a number, when I declared a decimal, automatically Python understood that this variable is a float type. Right? And this is what we mean by dynamically typed programming language. Now, the next is complex number 3 plus 4j. Let's create a complex number 3 plus 4j. So I will create it by the name of Z. Z is equal to 3 plus 4j, right? And type Z, if I do, it returns complex. So the data type of such variables will be complex. Next is, let's take an example of Boolean. Let's take an example of Boolean. Let's say var is equal to, now there are only two values that Boolean can handle. There are only two values that Boolean can have. That is either it's a true or false, right? And these true and false keywords are already present in the keyword list that we have, false and again, Python is a case sensitive language. Python is a case sensitive language. If I write true, something like this, it won't be considered, right? If I write TRUE, see the font color is changing. That means this is a keyword, correct? Type var, it will be a Boolean. It will be a Boolean variable, right? Then next is none type, right? If for none type we have a keyword called none, right? So what was the name? Empty. Let's take the name of empty. Empty is equal to none. Type empty. It is going to be a none type. It's going to be a none type, right? So these are the data types, explicitly used data types. I mean, not explicitly, but intensively used data types in Python. The integer, float, complex, Boolean, none type, and the last one is is equal to, now if I write type string, it's going to be an str. Str stands for string, right? Now over here, one thing I want to tell you is a string can be created in Python. A string can be created with, by using single quotes or double quotes. Anything that is written between two double quotes or anything that is written between two single quotes in Python would be considered as a text or a string, right? No matter. Now I've put double quotes over here. Let me replace those double quotes with single quotes. Execute. Fine. But now if I begin with a single quote and end with a double quote, that's a problem, right? You're beginning with a single quote and you have not terminated that single quote anywhere, right? So beginning with a single quote and ending with a double quote or a vice versa will be a problem. But if you use only double quotes or single quotes, it's perfectly fine. A string will be created in Python. Yeah, the string, right? Next is, okay, we have these as well, right? List, tuples, dictionaries, and set. Suppose, let me create a list, right? In Python, list is created using a square bracket, and inside square bracket, we have the elements, which are comma separated elements. Comma separated elements, right? So whenever in Python you encounter any square bracket with comma separated elements in them, the data type of such a variable will be a list, correct? So if you see over here, these were single data types, right? Single value, 25, 3.75, 3 plus 4j, right? These were single value data types, right? Or singular data types. But now we have moved on to multiple value data types, right? A list, a tuple, set, they are capable of holding multiple values. I've written 6 elements inside a list, correct? Now let's create a tuple. A tuple in Python is created using parentheses. Using parentheses. 1, 2, 3, 4, 5, 6. So the most basic tuple. A tuple in Python is created using parentheses. When I check the data type of tuple, it returns me a then I have something called dictionaries. Right? Dictionaries are created using curly brackets, and dictionaries are key value pairs. They are key value pairs, right? Like Karnataka. So I'm creating a key value pair of state and capital, right? Karnataka, Bengaluru. Okay. Then we have Tamil Nadu, Chennai. Okay. Okay, so we'll create for only two, right? Now see how a dictionary is created. It's created using curly brackets, and inside this curly brackets, opposed to the list and tuple, where we have comma separated values, here we have the concept of key value pair. Key value pair, and key values are separated by a colon. So anything on the left hand side of the colon will be a key, and anything on the right hand side of the colon will be a value, right? So a key value pair, that is what we have over here, correct? Now if I check the type of this variable, if I check the type of this variable, it will be a dictionary. It will be a dictionary, right? And finally, I have one more data type which is created using a curly bracket, but just the difference is I have comma separated values just like list and tuple, right? In dictionary, there is a key value pair, but in set, there are comma separated values in the curly brackets, right? And if I check the type of the variable, it will be a set, right? So these are some important data types that we keep on using in Python on a regular basis, right? Python is not complete without any one of these data types, right? These are the ones that are used extensively. Integers, float, complex numbers, they are not much of use. Integer, float, boolean value, none type, string, list, tuple, dictionary, and set, right? Yeah. So these are some data types which are extensively used in Python. Okay. So fundamental data types are integers, a is equal to 10, print type A, print ID of A, right? ID of A basically gives you the address, right? Type of A gives you the data type, right? It gives you the data type. Then, yeah, so we have integers, then we have float, right? We have already seen that. Then we have complex, we have boolean, we have none type, correct? And then strings. Okay, so now we are beginning with strings in Python directly. So, okay, fine. But before we begin with strings in Python, let us talk about this, right? These are the arithmetic operations in Python. Just like our calculators, Python is able to do these arithmetic operations, correct? Some of the arithmetic operations in Python, bitwise operator, these work on bits, and comparison operator, I'll talk about comparison operator in some time. Okay, so arithmetic operators in Python, right? Let's focus on the number part. Okay, now let us do one thing. We will declare a variable, right? We'll declare two variables. X is equal to, let's say, 10, and y is equal to, let's say, 2. Okay. Now, arithmetic operation number 1, that is addition. Addition. Okay. X plus y. X plus y. This returns me the addition of value of x and addition of value of y. So 10 plus 2, it should return me 12. Correct? The first arithmetic operator is addition. The second one, subtraction. X minus Y. Now it's not mandatory that I'm giving space, so you should even give space, right? It's not mandatory. Even if you don't give space in this X minus Y, it's going to be perfectly fine. Okay, so X minus Y, it returns me 8. Correct? Yeah. Next is multiplication. Multiplication. That is X into Y. X into Y. I'll make it small. X into Y. 10 into 2. That is 20. Division. X divided by Y gives me 5.0. By default, a division in Python, by default, the output of division will always be a float. Right? So 10 divided by 2 is 5, but it will return 5.0. Right? Now, we have something called exponent. Exponent, that is x raised to y, x raised to y, right? We write something like this. In exponent, we write 10 raised to 2, right? It's 100. So this in Python can be written as x double star. This double star is nothing but the exponential operator, right? 10 raised to y, 10 raised to 2, that's 100. The next is modulo operator. The next is modulo operator. X modulo is nothing but a percentage sign. Y. X modulo Y. What does it return? Can anyone tell me? How does it return me 0? X modulo Y. X is 10, Y is 2. X modulo Y has returned me 0. How? Can anyone tell me? What does it return?
So it is a sum of the dividend to divide.
So the remainder.
Exactly, correct. 10, 2, 5, 10, 0. This is what it is. Right? The modulo returns me the remainder. Modulo returns me the remainder, right? And this modulo is the logic that we use while we check whether a number is even or odd, right? And finally, we have the floor division. We have the floor division. So x, y, it returns me 5. Correct? Floor division. Okay? Or let's say 10 floor division 3, it will return me 3. So basically this returns me the coefficient, the quotient, right? This returns me the quotient, the numerical quotient, right? So these are some of the arithmetic operators that we generally use in Python. Simple arithmetic operators, right? We've been using this for since our childhood. Then we have the comparison operator. Now, what are these comparison operators? Comparison operators are used to compare two values, right? If comparison operator are used to compare two values, if the comparison is correct, it returns me true. And if the comparison is incorrect, it returns me false. For example, I am writing 10 equal to, or let's say I am writing 10 less than 2. Is it true or false? If I write this statement in Python, it will return me false. If I write 10 greater than 2 in Python, it returns me true. So this is a comparison operator. Comparison operators are double equal to, not equal to, greater than, less than, greater than equal to, less than equal to. Okay? So let's say x is 10, y is 2. Okay? X double equal to y. Now here we are not using single equal to, guys. Here we are not using single equal to. Why? Because the single equal to we have already used as a assignment operator. Single equal to we have already used as an assignment operator. Wherever in Python you write single equal to, it means you are allocating a value to a variable, right? But on the contrary, if you want to compare two variables, whether they are equal or not, we use a double equal to. So this is going to compare whether x and y are equal or not. So x is 10, y is 2. The expected answer is false. Let's check for another operator. X greater than y, 10 greater than 2, it's going to compare. True. X greater than equal to y. True. X less than y. False. X less than equal to y. False. Right? X not equal to y. Not equal to y means both are not having the same value. Okay? So x is 10, y is 2. Expected answer is true. Right? So these are some of the comparison operators that we have, right? Double equal to, not equal to, greater than, less than, greater than equal to, and less than equal to. And then we have the assignment operators, right? So assignment operators we will have a look at when we check the loop. Okay, when we check the loop, we'll have a look at that, right? Okay, but okay, still I'll tell you these increment operators and brief, right? Now suppose x is 10, y is 2, we already know. Now suppose I want to increment the value of x. I want to increment the value of x by, let's say I want to increment the value of x by 1. Okay. How I write? X is equal to x plus 1. Okay. And then I print value of x, it will become 11. Correct? The same thing can be written, the same thing, right, can be written in Python as x plus equal to 1. X plus equal to 1. Now when I write print x, see, it has automatically incremented the value by 1. Updated value over here was 11. Now the incremented value is 12. Why? Plus equal to x plus equal to 1 is the same as x is equal to x plus 1.
That will continue from.
Yeah.
That will continue from there. ID one.
Yeah. Now I updated earlier before this cell until here, the value of x was 10. In this cell, the value of x updated to 11. In this cell, the value of x already is 11. Now I'm adding one more to it. So it's x. No, x is equal to plus 1. X plus is equal to 1 is going to, right? You cannot interchange this, right? You cannot interchange. Okay. Now, suppose I want to write y is equal to y minus 1. If I want to write this, I'll simply write y minus is equal to 1. Let's check the value of y. See, earlier it was 2, now it's 1. Now the same thing can go over and over with multiplication, right? With division, you can use these values, right? So see over here, plus equal to, minus equal to, multiplication equal to, division equal to, modulo equal to. Okay. So these are some of the arithmetic operations that you can do in Python. Okay, with numbers. I mean, arithmetic basically means numbers. Okay. Now we'll move on to now we'll move on to the concept of strings in Python. Okay, strings in Python. Now, a string in Python is anything in single or double quotes. As simple as that. You declare anything in Python, anything in single or double quotes, it will be treated as a string, right? So let's say my str. Let's say my str is equal to the most basic one, right? Hello world, right? My str is hello world. Print my str, it will print hello world. So now this my str is a variable which is storing a value of string, right? Which is storing a value of string, and the string is hello world, right? Now, now you can even write it in single quotes. You can even write it in single quotes. It's perfectly fine. You see, again, it's a string. Okay. Now, okay. So string, they are talking about what string? Okay. Now, string concatenation. String concatenation is basically when you try to join two strings together. As simple as that, right? When you try to join two strings together, it's called string concatenation. Now, suppose str1 is, let's say, um, hello, right? str2 is equal to world. Now conventionally adding of two strings or adding of two alphabetical values does not make sense. New numbers can be added, alphabets cannot be added, right? But over here, when I do str1 plus str2, what has it done? It has joined both the strings. It joined both the strings, right? And this concept of joining two strings in such a way is called concatenation. Concatenation of string, right? It's called concatenation of string, right? Directly we are adding. Now, if you want to put a space in between, like these people have done, sorry, just add a space in between, right? Just add a space in between. Oh, sorry, I have to add space. An empty space. Okay, proceed. Hello world. Then we have the concept of there's a function called length of the string, len my string. So length is a function that returns number of characters that are present in a string. For example, let's see how many characters we have over here. 1, 2, 3, 4, 5, 6. Empty space character or a white space character is considered as a character in Python. 7, 8, 9, 10, 11, 12. That is the length of your string, right? So whenever you create a string like hello world, space, right? 1, 2, 3, 4, 5. This is the sixth character, right? So an empty space will also be considered as a character in Python, right? And that is why it's returning me 12 letters. I mean 12 characters, right? Now, there's an interesting concept, guys, called indexing of a string. Indexing of a string, right? Now, what is this? Whenever you create whenever you create a string in Python, by default it will get stored in Python in such a way that every character, when I say character, I mean a single alphabet. When I say character, this is a character, this is a character, this is a character, right? So every character will be given a index value. Index value is just like the index that we have in our books. In our book, we have the topic, the page number, topic, page number. Go to the page number, you will be able to access that topic, correct? So just for simple indexing in Python as well, string is stored by index values of every single character. And in Python, by default, indexing begins with number 0. So H is at index 0, E is at index 1, L is at index 2, L is at index 3, O is at index 4, 5, 6, 7, 8, 9, 10, 11. Because we are beginning with 0, we are ending at 11. Right? Now, suppose, let us say that I want to access the first letter or the first character of my string. I want to access the first character of my string, that is H. In our case, it is H. right? I want to access the first character of our string, that is H. How do I write it? It's very simple, guys. The string, that is my str, wherever you call my str, it's going to return you the string. Okay, my str followed by a square bracket, and in this square bracket you need to pass the index value of what you are trying to access. So index value 0 is going to return me the character that is stored at index 0. So my str square bracket 0 returns me H, right? My str 0 returns me H. If I want to access the last letter, my str square bracket 11, the last index, that is the exclamation. Now, just like a forward index in Python, we have a concept of reverse index as well. Forward index goes in this direction, reverse index goes in this direction. -1, -2, 3, 4, -5, -6, -7, -8, -9, -10, -11. So if I want to access my string from the reverse order, I can use the negative indexing as well. My str -1. It should return me the last character of my string, that is an exclamation mark. And this is what it's returning me, correct? So basically my str11 or my str -1, they are returning me same value because 11th is the last index in the forward indexing and -1 is the first index in the backward indexing, right? That is why both are returning me the last character. Okay. So this is basically how we start our indexing of a string, right? Text 0, it returns me the first index. Text 2, it returns me the character at the second index, right? Yeah, then we have slicing. What all they have over here? Slicing, okay, conversion, okay, uppercase, lowercase, flipping, there is contain. Okay, okay. Fine. We can take these methods, right? Okay. Now, slicing in Python. Slicing in Python. This is what we have seen is indexing, right? Indexing is basically we try to index a single value. That's what we call indexing in Python. Slicing, suppose now out of this entire string, I just want to slice this part, that is hello. That's it. I just want to slice this one this thing, one word, hello, right? So for this, my str, I will have to pass a range, right? And the range will be range of indices. Sorry, yeah, exactly. 0, beginning with 0 till 5. By default, in Python, in slicing in Python, the last index is ignored by default. is ignored. So when I say slice from 0 to 5, it will return me all the characters from 0 till 4, even including fourth one. Okay. So my str 0 followed by colon followed by 5 will return me hello. See? Return me hello. Correct? Now suppose you want the numbers only, let's say, uh, I mean alternately. If you want numbers alternately, right? You don't want all the H E L L O, right? You want numbers alternately H L O, something like this, right? In indexing, sorry, in slicing, you can very well pass the step size as well. You can very well pass the step size of 0, 5, a step size of 2. 2 stands for from 0, beginning with 0, I want every second character. So H, E will be skipped, L, the next L will be skipped, O. So this H, this L, this execute it returns me H, L, and O. Right? So this is the beginning index, final index, and the step size. Step size, right? You can pass any step size. If you pass 3, it's going to return you accordingly, right? So this is how we what do you call slice in Python. Okay. Now these basically are functions that we can talk about. Now suppose with string, if you want to convert a string to uppercase, lowercase, right? For that, you explicitly have the methods of upper and lower. For example, my str dot upper. See what's happened? It's converted all the alphabets into the uppercase, capital letters, right? Originally, how it was? Originally, it was the sentence case, right? H was capital, E L L O small, W capital, O R A L D small, correct? When I do dot upper, I use the method of upper with a string to convert all the entire string into capital case, right? Now, if I want to convert the entire string into small case, my str dot lower. It's going to convert the entire string into small case, right? So I mean these are some of the functions that basically are used with string, right? So if you do a dot title, my str dot title, it's going to convert into sentence case. It's going to convert into sentence case, right? Then we have the strip method, remove the leading and trailing white spaces from string. So let's copy this. Okay. Now suppose right. Okay. So now suppose this is my string Python is fun. Okay, there is a leading space, a leading white space if you see, and there's a lagging white space, right? I mean, there's an empty space before Python and after the exclamation mark. Now, when I use the strip method, what happens is this leading space and the lagging space, both of them are going to get vanished, right? Both will be removed from the string, right? So execute this. So see, print my string. See where it's printing? It's printing over here. Why? Because the leading space is getting printed over here. But when I did dot strip, see where it's printed? It's begin printing from here itself. Why? Because the strip method is going to remove the leading and lagging spaces from a string. If I use L strip, if I use L strip, L strip is basically going to remove the left hand side, right? On the left hand side, strip the space on the left hand side, right? On the left hand side. If I use R strip, it's going to remove the space from the right hand side. It will keep the space on the left hand side, but it will remove from the right hand side. Okay. So R strip, see, the left hand side space is as it is, right hand side space will be removed. Okay. Then what all they have? The strip method and we have defined count starts with inputs print join. Okay, fine. We can. Okay, we still have 20 minutes, right? I'll tell the type conversion and then we can basically leave, right? Sure. Yeah. Now, type conversion. Type conversion. Suppose I have str1, which is, let's say, 100, which is an integer, right? I've Even if I pass an integer in double quotes, it will be it will be considered as a string. Okay. So let me check the type. Okay. So the type is a string, right? Type is a string. In Python, for such cases, you can very well do the type conversion. What do I mean by that? Type conversion, I mean, I don't want this number to be a string. I don't want 100 to be a string. By mistake, it was written as a string. I don't want it to be a string. I need to convert it to an integer. I need to convert it to an integer. How do I do it? I use the concept of type conversion. Num1 is equal to convert into an integer. I use the function int. I use the function int followed by the string which I need to convert, right? Now let me print num1 and let me print the type of num1. Check. The type of string1 that is 100 in double quotes was a string, but when I did a type conversion, to integer, it explicitly got converted, this string explicitly got converted to an integer, and when I check the type of this variable, it's an integer, right? Similarly, I can do for float as well. Let's say that str2, sorry, 2 is equal to, let me create a single 123.45. Now this is a float. Check the type of str2. It's going to be a string, but now I want to convert this into float. Num2 is equal to float string 2. Print num2 and print the data type of the converted string, right? So type 2. Earlier it was a string, now it's a. Got that, guys? So this is the type conversion, right? Type conversion. That is, we can convert in any such cases, right? Because the thing is, you will not be able to convert an alphabet to number, right? You will not be able to convert. Let's try doing that as well. Right? But it does not make any sense. Suppose str3 is equal to, let's say, hi. Let me try to convert it to a number. Num3 is equal to int, or let's say float of str3. Try doing this, could not convert string to float. There was a reason earlier ones got converted, because this was actually a number which was written as a string. This was a float which was written as a string, correct? But now over here we are trying to convert an alphabet into a number, into a float. That does not make sense, and that is why it returned us value error. Could not convert string to float. As simple as that. So such cases will not be able to convert. Okay, but the above cases you will very well be able to convert. And one more case that I wanted to focus upon is, suppose you have num4 is equal to 1, 2, 3, 4, 5.67, something like this. Now, if I try to convert this to a string, I use a function called str, right? Str num4 print type of str4. See, it has now converted to a string. So any number can be converted to string, right? But only specific strings can be converted to number or integer, right? Such cases, you will not be able to convert a string to a number. It will throw you an error. Make sense, guys? So let's do one thing. The remaining we can take. Yeah, we'll just see this one flow diagram. Operators in Python, we have the arithmetic operators, the comparison operators, logical operators, bitwise operators, assignment, and membership operators. Right? Membership operators and all we basically use in the conditionals and loops. Okay. Perfect. Fine, guys. So we'll stop the session here, and we can basically take over any questions, any doubts, any issues. Guys, online, offline, anyone has any questions or any doubts or any issues, you can basically ask them right now, right? And the remaining part, the remaining part of the string will cover in the next session, that is tomorrow's session. Any questions, guys? Anyone? The online guys?
No,
No,
sir.
sir.
Okay. Okay, so guys, thanks for attending the session. Thanks for listening patiently. Hope you're able to learn something new. And yeah, have a nice Saturday, and we'll meet tomorrow at the same time. Thanks, everyone.
Thank you, sir.